Hello, I'm William Gibb, and today I'm going to be introducing the Kaiser bolted bracket. The Kaiser bracket comes in two basic forms. The one shown on the right was the original design, which is primarily used for retrofits. It is bolted in both directions of the beam and the column. The one shown on the left is the new construction version, which has a heavy shop fillet weld, and then it is bolted for installation in the field. The way the bracket works is to form a plastic hinge away from the column face. The bracket is sized to develop the probable maximum moment capacity of the connecting beam. The bracket and connection are not dependent on the material or workmanship the same way that a field welded joint is. Here are a couple of advantages for using the bolted bracket. First, it should lower fabrication costs. It does not require continuity plates or doubler plates in most cases, or the weld access holes, and the RBS requires an additional cutout for the beam, which increases the weight. Therefore, it reduces the steel usage. It is also not critically dependent on field workmanship because it's just a bolted connection. This should lower erection costs because there's no field welding and no special inspections. And really significant is the faster erection times. This slide shows a typical installation of a retrofit version on the right and a new construction version on the left. Here are a couple of features about the Kaiser bracket. First, there is no field welding. The bolting eliminates both the welding and special inspections. In most cases, we can eliminate continuity plates and doubler plates. There was actually testing was done without these. Smaller beam sizes. It's been approved for progressive collapse. And really important is how easy the fit up is because you have short vertical slots that allow the alignment to the column to be very simple to put in. It's quick to put up and you can drop the crane after just putting in a couple of bolts. The bracket only requires a heavy shop fillet weld using a standard preheat. There are no special inspections. We can also do some custom designing such as roof slopes. It's supported in the recent RISA release as they have done all of the pre-qualified connections. Interesting to note that the weak axis can be clear without continuity plates or doubler plates, which makes it easier to design. There are no fees because we sell castings, we sell the parts. Although the Kaiser bracket may seem relatively new to the market, it actually has a long and proven history. ICF Kaiser Engineering did 22 projects of new and retrofit buildings. These included the West LA Medical Center, a retrofit of Amgen in LA, 3 terminals in the LAX airport. Since Steelcast Connections took over the bracket, I have sold in all of these states. I wanted to go through this example and case study where the City of Seattle only allowed them to work on weekends within a noise ordinance because they were not allowed to take the overhead wires down from the buses. Using the KBB, the erectors cut the time from 3 weekends down to 1 3-day weekend. The city charges $100,000 every time they take the wires down. Notice that this fabricator painted the protected zone in a darker color. Because we were able to eliminate the continuity plates, a connection as the one shown is much easier to achieve. Let's talk briefly about the steel casting specification. The casting grade is technically an A958 material. This consists of an ASTM A148 SC 8620 class 8050. This means that it has an 80 ultimate yield or 50 minimum. It also has a 22% elongation. Along with this, the A958 code requires certain testing procedures. Additional to these, the Appendix A of the 358 code also contains testing. The ANSI AISC 358 code, Appendix A, contains all of the additional testing requirements for the brackets. It should also be noted that steel castings consist of 100% recycled materials and therefore may provide LEED credits to your project. The engineering and size calculations for the bracket is a relatively simple procedure. The first way is to follow the AISC design procedure as published, along with the recommendations in the commentary. The spreadsheet that we created also makes it much easier to do the size and checks. Scott Aiden, PhD, is also available for questioning. He's the person who created the spreadsheet and also represented the bracket during its review process with the ANSI code. The bracket is pre-qualified in the ANSI AISC 358-10 code. The bracket is actually Chapter 9, all the details, and the casting specification is Appendix A. You can go to our website or to the AISC site to get these and download them. Here are a couple of design parameters. A few things that you need to note about the column is that it must satisfy the strong column weak beam. The best option are W12 or 14 columns. In these cases, we can eliminate the continuity plate. The other option, in some cases, we can use deep columns. These can be the most economical by the least weight versus stiffness. There are more limits on these. They must be 12 inches wide, which is a bracket's width minimum. The flange must be heavy enough to avoid column flange tensile rupture and prying action. And they also may require continuity plates. Here's the examples taken straight from the design table from the 358 code, showing which size brackets are best suited to which size beam designs. This is a quick look at the spreadsheet that Scott created that makes it very easy to calculate the size. It's also worth noting that the KBB has been approved for application involving progressive collapse. In some cases, it may be possible to put a bracket on the bottom with a plate on the top at the roof line. It's also good to note that parts can be designed for roof slopes. I'm currently working on a project right now that has a 7-degree roof slope. The other thing that we can alter is bolt locations and sizes, depending on the special situations that these are going into. An example of a couple of roof slopes. This was an interesting retrofit project we did in San Diego because they actually used new construction brackets and material inside of the building. In order to do the 90-degree angles that we see here, they had to drop some of the bolts up higher and some of the bolts lower. Here are a couple of details and issues to be aware of. One issue is that in some of the larger brackets, the casting may protrude a little ways into the floor. One solution is to fur out beyond the protrusion. We actually supply a table that shows how far into the floor these protrude. It's typical for the ones that have only one row of bolts to actually fit within the floor range, and then a little bit out, sticking out with the 2 rows of bolts, and then a bit further for the 3. This table, though, covers all of those dimensions. In addition to this, one other small issue is that the AISC recently ruled that all bolted connections must require a compressible material to be installed around the bolt because nobody has tested the bolts against concrete. It is possible to use standard finger shims if needed, though it is typically not necessary. Let's talk a little bit about bolting. All of the bolts are supplied from steel cast connections with the brackets. The bolt lengths need to be calculated. Typical column bolt sizes are 1 3/8 inch or 1 1/2 inch in diameter. Beam bolts are supplied by SCC for retrofits as well. Bolts are all typically ASTM A490 material. Also, the standard shear tab bolts we do not include. There are several different types of bolting available to you. First is the TC twist-off bolts, the DTI squirter washers, the calibrated wrench, or the standard turn of the nut. TC twist-off bolts, tension control bolts, come in sizes of 1 1/8 inch or smaller. This makes them an excellent choice for the beams in a retrofit project, but they tend to be too small for most new construction installations. I have one erector who loves the DTI squirter washers. In this case, you have a little pocket of dye and a slot, and as the washer is compressed, it squirts dye out to indicate that it's reached full pre-tension level. The calibrated wrench, of course, is one of the most dependable and substantial methods. It's an excellent method for doing these. Finally is the standard turn of the nut. The most basic but efficient method requires that you finger tighten the bolts. Pre-tension is achieved by marking the bolt, then turning it a specified distance, typically 1/3 rotation. All of the details to be followed are in the RCSC specification. I would like to present a quick view of a retrofit project that we did in California. First, I'd like to mention a couple of advantages of using an all-bolted connection for retrofits. Bolting avoids hazards associated with welding, such as fires from sparks or sprinkler system malfunctions. Welding is going to require continuous inspection, highly skilled welders, extensive fire protection measures, and special ventilation systems of the noxious fumes. Also, careful scheduling of welders and inspectors. Without the need to create a special ventilation system, it's easy just to create simple containment booths. This makes it possible to do work at night in an occupied building. Cut access to both the top and the bottom for the beam and the column. You then would use a magnetic drill and a template and drill the column bolt holes. We have a fixture that you can create to just simply lift the bracket up into place. Once it's in place, you use C-clamps to hold it. Then you can use a magnetic drill to drill through the beam holes. Let's walk through a little project outside of Portland, Oregon. This shows the moment frame connections. We're going to use this table from the AISC's 358 code as a starting point in order to see what size bracket go with what size beams. From there, we're going to use the spreadsheet that we created to do the checks on it. It'll tell us all the details. Here this shows what size brackets were selected for this project. Okay, now in the foundry we're going to make these parts. We're going to pour at 3,000 degrees Fahrenheit. The parts come out with the risers and ready to be finished up. This is just a rough casting. We're going to do a preheat of 450 degrees in Fahrenheit in the fabrication shop, which is a standard preheat. Weld in the shop. It's a heavy shop fillet weld, but you'll notice also that there are short vertical slots in the casting for the column. This makes it very easy to do alignment. Also, the total size and length of the weld is determined in the calculations I showed on the spreadsheet a few minutes ago. Notice that we did not have to do any welding on the end. Typically, we just overlap them a little bit. In this example, I wanted to show that the bracket can actually be wider than the beam. It's okay as long as we get enough fillet weld length in there. It is important, however, to note that the column has to be as wide as the bracket. In this case, the erectors create an extension for their wrench to make it easier. Note also the orange dye. We'll be talking about DTI squirter washers in a moment. Here's the finished frame. You'll notice that the brackets stick up just a little bit at the roof line. And here's the finished building, one of my favorites. Steel Cast Connections has done a number of publications. Steel Connections for Proprietary or Public Domain was an article written in Modern Steel Construction in October of 2011. I personally wrote an article about steel castings in Structure magazine in July 2009. From here, we also did an HSS tubular nodes customized steel castings for a project in Boston. A very complex project with HSS tubular nodes. For retrofits, there was a document presented to the 2010 convention in SEOC. Basically, from this evolved an article in Engineering Journal, which was put out just in July 2015. There was also a NIST technical brief. Possibly the most important is the 2009 Engineering Journal article that was created specifically about the details of the bracket. Here is a comparison of the bracket to other methods. First, the RBS dog bone. Each connection is individually designed with complex fabrication detail. They're field welded, that's the significant part. They require special inspections and continuity plates. The KBB should be about 20% less in weight because of the cutout required for the dog bone. So it saves hours and even days in erection time. This is probably the most important of all on the list. Compared to the bolted in plate, you have a complex full penetration shop weld. There can be alignment issues trying to align this big plate, particularly if warping comes into play, whereas the bracket has just short vertical slots with separate pieces, so it's very easy to align. Other patented approaches, they can require complex welding. Really important, they all do the engineering. In our case, we're selling parts, so we don't do the engineering. We will help you and give you the tools you need to do that. They save money primarily by reducing member sizes, but we do the same thing. Just briefly, here were a couple of cases of actual installations that were clocked. We do not need to charge any license or engineering fees. We simply give you the tools and you order parts. We have done a couple of cost studies on both types. The new construction version, they show that the KBB beat the competition by about 10 to 20%. It's in particular important to note that this does not include the savings achieved as a result of the quick erection times. Now for the all bolted version, or the typically retrofit version, we had an engineering firm that did some studies on this. They compared it to dampers, added frames, and other methods, and they said this is by far the most economical system overall. The actual cost in a 2016 project as clocked was around $650 per bracket, the installation time. This does not include removal or fireproofing. I wanted to introduce one more concept that we are just coming out with called the Kaiser ordinary moment frame. Basically, there are two forms of this. One is for a box column and the other is for a W type section. It is essentially just a smaller version of the Kaiser bracket that fits within the frame that we're developing. Installation procedure, all you need to do is design the frame size. You can use the spreadsheet that we provide to help you do this. You purchase brackets from us and the bolts, and then you prepare them in your fabrication shop. That means the whole frame, you're going to be making the frame. Install the bolted connection in the field, and this saves installation, shipping costs, and time. And like I said, you get the opportunity to make these frames, not buy a complete frame. One more quick concept is to be able to use these as column bases. I wanted to show you just a couple of pictures from projects that we have done. This is in Oregon. This is another little job we did in Oregon, but you can see the brackets in place. Cartwright Engineering in Utah approached us to actually do the work for their own office building. In the end, they ended up doing 2 office buildings, and then beyond that, I've done a medical center in Idaho, a retrofit in San Diego, a school in Bellevue, Washington, and most recently, a car dealership in Memphis, Tennessee. With a long proven history, the Kaiser bolted bracket is an effective connection for both the retrofit of existing buildings and construction of new special moment frames. The KBB has been extensively tested and certified in the ANSI AISC 358-10 code for pre-qualified connections.
The Kaiser connection provides value to the owner through a number of areas. 1, it's relatively easy to engineer. 2, it provides a simple fabrication in the shop. 3, it allows fast erection in the field. And 4, it eliminates field inspection associated with ultrasonic testing of full penetration welds. This is a huge savings. It puts a tool back in the structural engineer's toolbox.
Well, I've become a real bracket fan because we can do a lot more work in a lot less time.
Everyone knows that time is money, and it's no different on this project. We were able to realize a significant savings using this Kaiser bracket.
It's the next great and yet simple solution to building and retrofit needs everywhere.
Thank you for watching. We have a lot more information and available downloads at our website at steelcastconnections.com.